If you place $1,000 into an account paying a nominal rate of 4% compounded continuously, we want to find the formula for the balance after T years. Now, there's two formulas. Let me just write down the one we're not going to use and remind you why. This is the formula we like to use if it's compounded n times per year. Continuously is that you sometimes hear called the PERT formula because it looks like it spells PERT, P-E to the R-T. And that's a nice one because we don't have to worry about the number of times it's compounded per year. So we have B equals our principal amount of 1,000 e to the 0.04 t. So right off the bat, we want to make sure we use the right formula because if we don't, the whole rest of our problem will be wrong. Now, let's see if we can find the annual growth rate or the effective yield. Now we have our growth factor, which is this component right here. So to get the annual yield, we take our growth factor, our annual growth factor, I should say, e to the 0.04. So let's just calculate this and you can kind of see what's going to happen. So here's the e to the 0.04. Notice there's the 1 for the 100%, and then here's what's going up. So the next thing we do is we subtract 1. So there it is as a decimal, and then we turn it into a percent by basically multiplying by 100. And rounding to two places is 4.08% is the effective yield. Now, how much in the account after 10 years? That's putting in 10 for T. Just want to show you something, a mistake that happens often. If I do my calculator puts in the parentheses, so that actually is going to save me from that mistake. But if I close the parentheses and then put the 10, that it's not going to work. Because the calculator already puts in the parentheses for us, that should help us avoid that mistake because we want to make sure both the 0.04 and the 10 are in the exponent. There's our balance after 10 years. Don't forget your units, dollars. $1,491.82, round to two decimal places because we're dealing with dollars and change. How long does it take the account to double? One way of doing this is setting this equal to 2,000. First thing you're going to do, though, is divide by 1,000 on both sides. So basically, we want to solve this exponential equation, e to the 0.04t. We want to know when it equals 2, because you can think of this as 1 doubling to 2. This we can solve via logs, specifically natural log, because natural log of 2 equals 0.04t from what we know of rewriting exponential equations as logarithmic. Divide both sides by 0.04, and we should have our t. So we take ln of 2 divided by 0.04, and there's our t. Oops, a little bit caught off the screen. About 13.33 years. 17.33 years, rounded to two decimal places.